Hello everyone! This video is intended for those who have experience in manufacturing with metal 3D printers. The LUMEX is a hybrid machine that combines laser powder bed fusion metal additive manufacturing with high precision spindle machining. It features unique capabilities designed to address many of the common challenges associated with conventional metal 3D printers. Now, let's take a closer look at each of these key points. In many cases, parts produced by Metal AM cannot be used as final products straight out of the machine. To achieve the required dimensional accuracy and surface quality, secondary machining processes are often necessary. Another common approach in AM is integrated design with complex geometries. However, the more components are consolidated into a single part, the more likely it becomes that certain areas are inaccessible to cutting tools. As a result, post-processing may be impossible in those areas, and in some cases, design compromises become unavoidable. But what if internal features, areas that would normally be inaccessible after the build is complete, could be machined while still inside a 3D printer? Wouldn't that significantly expand your design freedom? LUMEX adopts a hybrid process that alternates between additive building and machining. This allows machining to be performed during intermediate build stages when the cross-section of the part is still open and accessible to cutting tools, even within internal geometries. When performing high-precision post-processing on AM parts, there are two major challenges. The first is how to securely clamp the workpiece. The second is how to establish the coordinate system. With cast components, it is common practice to allow for some positional variation and provide additional machining allowance in advance. In contrast, metal 3D printing aims to produce parts as close to near-net shape as possible, with the thin walls and minimal excess material. Under these conditions, setting the machining origin during post-processing becomes a significant challenge. A common solution is to use a CMM to measure multiple feature points and calculate the origin. However, due to surface roughness variations on additively manufactured surface, a large number of measurement points is often required, which increases setup time and complexity. With LUMEX, the built-in machining function is used during the build process to create small high-precision reference surfaces in advance. During post-processing, these reference surfaces can be probed to accurately align the workpiece. As a result, setup time in post-processes can be significantly reduced. In reality, accurately building additional features onto an existing part is not a simple task for a metal 3D printer. One reason is that the laser coordinate system has no physical contact reference, making positional deviation more likely to occur. As a result, with conventional metal 3D printers, significant trial and error is often required to position existing components correctly and ensure repeatability. In contrast, LUMEX utilizes its integrated spindle to perform probing measurements. This makes it possible to accurately establish the coordinate system of an existing part. When high-precision additive building onto existing components becomes possible, integration with conventional machining processes become much smoother. For example, material can be additively built only where needed onto a base part that has been machined in advance, enabling truly hybrid manufacturing. This capability also opens up strong potential for part repair applications. LUMEX is equipped with an XYZ 3-axis table coordinate system. This makes it possible to calibrate the optical system coordinates based on the straightness and squareness of each machine axis. For this calibration process, a CCD camera mounted next to the spindle is used. Specifically, at predetermined layer intervals, a cross mark is drawn with a laser and then captured by the CCD camera to verify whether any positional deviation has occurred in the optical system. In addition, Lumix can draw a grid pattern using a laser and read the intersection points to perform geometric compensation. By carrying out this calibration as part of regular maintenance, long-term changes in the optical system can also be effectively managed. What did you think? As you've seen, there are manufacturing possibilities that can only be realized with a hybrid metal 3D printer. If you believe these capabilities could add value to your production, we will be pleased to hear from you. Please feel free to contact Matsuura. Thank you very much for watching.